Alright, today we're going to be covering integration by partial fractions. I prefer to call it partial fraction decomposition because that's actually what you're doing. Anyway, so like usual, I think the best way to explain this concept to you guys is through an example, okay? So let's start with an example. Let's say we want to find the integral of 5x minus 13 all over x squared minus 5x plus 6, okay? So this is a rational function, okay? We aren't able to solve this integral directly, okay? So what we're going to do is we're going to decompose it into fractions that we can find the integral of. So step one is to factorize both sides of your equation, okay? This is as factored as it can get. We can't factor anything more out of this. This, however, can be factored. And I can rewrite the partial fraction as 5x minus 13 all over x minus 3 times x minus 2. Okay? Now that I have everything in my factored form, I can set up what's going to be my decomposition. Okay? So my decomposition is I'm going to say this is equal to a, something a over x minus 3 plus some item b over x minus 2, okay? I'm going to set this statement true. One is over one of the factors, one is over the other factor. Now, the next step I have to do is I need to multiply each of these by the other factor. So I'm going to take a times x minus 2 all over x minus 3 times x minus 2 plus b times x minus 3 all over x minus 3 times x minus 2. So now what I have here is I have two fractions that each have the same denominator. So I can combine these and say ax minus 2a, which is this, I just distributed the a into my parentheses, plus bx minus 3b all over x minus 3, x minus 2. Okay, now this is what I'm dealing with. And remember, I had this equal sign up here. So I'm going to bring this down. I'm going to have ax minus 2a plus bx minus 3b all over x minus 3, x minus 2. And remember, this was exactly the same as what I had up here. So I'm going to take this equal sign and I'm going to set it equal to 5x minus 13 all over x minus 3, x minus 2. Okay? Now we've followed some arbitrary rules and we've gotten here. Now we can get some work done. Okay? So this is what you need to memorize up until this point. First, you take your top and bottom and you factorize them as much as you can. Then you write a over factor 1 plus b over factor 2 equals this. Then you multiply each fraction by x minus 2 over x minus 2 in this case, and x minus 3 over x minus 3 in this case. You multiply it by the factor that you don't have, okay? And since I'm multiplying by x minus 3 over x minus 3, I'm technically multiplying by 1. I'm not changing anything about the fraction, okay? Next step is I distribute the a into my factor. I distribute the b into its factor. And then, since I have two fractions with the same denominator, I can add them and I can get here. And this equal sign carries down. Now what I can do is I can see these have exactly the same denominator. So I can just worry about making sure the numerators are equal, okay? And I can separate this into two categories. I have terms that have an x, and I have terms that don't have an x. So I have ax plus bx has to equal the terms that have an x, has to equal 5x, okay? Because a is a constant number, b is a constant number. B cannot be a function of x, okay? Which means the only way I can have items adding to 5x is if I add the items that already have x, okay? I cannot add 4 and 6 and get 5x, okay? I need to add something times x to something times x and get something times x. In a similar way, something times x cannot give me a constant. So only my negative 2a right here and my negative 3b, when I combine those have to give me my constant term, okay? Now I have a system of two equations that I'm going to solve. First thing I'm going to do, I'm going to look at my x equation. I see x in each term, so I'm going to erase x from each term. I'm going to divide the whole thing by x. I'm going to get a plus b equals 5. And now let's use the methods we learned back in pre-calc to solve this system of equations. Let's try it this way. What I'm going to do first is I'm going to double my top equation. I'm going to say 2a plus 2b equals 2 times 5, which is 10. Okay? And now I'm going to combine the top and bottom. I'm going to basically add these two together. So 2a plus negative 2a is going to be a big 0. 2b plus negative 3b is going to be a negative b. And I've got 10 minus 13 equals negative 3. So I've got right here, I got negative b equals negative 3, and I got b equals 3. Cool. I solved for one of my constants. Now I can just plug this back into one of my equations. Remember, this up here was originally a plus b equals 5. And now I can substitute b in, and I get a plus 3 equals 5. And now I can solve easily for a. I can say a equals 2. Very good. So now I can come up here, and this was originally what I wanted to come to. Now I've solved for a and I've solved for b, and I can plug those back up here. And I get the integral of 5x minus 13 all over x squared minus 5x plus 6 equals the integral of a over x minus 3, the integral of 2 over x minus 3, plus b, which was 3, all over x minus 2. Okay? So this is the simplification I have performed upon my integral. And I can simplify it further by saying this equals 2 times the integral of 1 over x minus 3 plus 3 times the integral of 1 over x minus 2. Now what I have here is two integrals that I know how to solve. First I'm going to do use substitution, then it's going to be the integral of 1 over x. So these I'm going to set u equal to x minus 3, 2 times the integral of 1 over u du, plus 3 times the integral of 1 over u du. In this case, u equals x minus 3. In this case, u equals x minus 2. If you want to watch the video on use substitution, that's going to be linked right up there. And now I'm going to say that this equals 2 times the natural log of the absolute value of u plus 3 times the natural log of the absolute value of u plus some arbitrary constant c. We're going to substitute our u's back out for our x's, equals 2 ln absolute value x minus 3 plus 3 ln absolute value x minus 2 plus c. And this is now our final answer. Okay? So the math itself behind partial fraction decomposition, the math is not hard. The hard part is memorizing the steps you got to take. Okay? We went through all the steps we have to go through to get here. Once we're here, we need to separate our x's. And let me reiterate this for you. We separated our x terms and our constant terms. We had an x, an ax, and a bx. So we had an ax plus a bx equals what's our x term on this side equals a 5x. We find our constants on the left, we set them equal to our constants on the right. And once we have two equations, we can solve them like a system of equations. Solve for b, solve for a, plug them back in up here, and then once we set this equal to this, we can set the integral equal to what we have solved for. We set a equal to 2, we set b equal to 3, and now these are two integrals that we know how to solve, okay? That's how we go through partial fraction decomposition. If you guys liked this video, if you're able, please leave a like. Otherwise, if you need extra help, you can go to meekextrahelp.com or you can join the Discord server, all linked down below. Anyway, have a fantastic day. Enjoy life.